let's get started. So, I mean, in general series, what should we know? A general series, you know, like it's a. So it's the question that you will get in that review question. Let's do some reviews here for each of the following series. Say if it converges absolutely. Conditionally. Or diverges. Of course, justified. Good answer. Okay. Let's do some review. Then maybe I'd appreciate also if you could participate. That would help us a bit. Let's see. Okay. Great. So what's the thing to try here? What's the first thing to try? Whenever you see a series, a series, what's the first thing to try?
Divergent.
Divergent meaning, like you take the limit and you see whether it goes to zero. If it doesn't go to zero, then you're good, because the series diverges. If it goes to zero, unfortunately, or fortunately, that's not enough to conclude. Now, what is this limit? Does this limit go to zero? Yeah or no?
No.
Where does it go to?
Indeterminate.
It's
Indeterminate.
so infinity over infinity, sure, but still could be zero, right? Even if it's indeterminate. What is this limit? So let's look at the limit on top. So I have infinity over infinity and indeterminate form. And we could use L'Hopital, but let's avoid it. Well, I don't know if it does. But what is the dominant term on top? On top there is only one term, right? On the bottom, what is the dominant term? Yeah. Great. So what is the dominant term on the bottom?
4 to the n.
4 to the n. So let's take out the dominant term here. So what do I do? 1. Is that right? Now let me arrange this. Where you are. Sit where you are, yeah. This is the best place actually. Okay, great. Now, what can I do? What can we say here? 3 over 4 to the n. 3 over 4 in absolute value is less than 1, isn't it?
Yes.
So where does it go to?
0.
Okay, so 3 over 4 to the n is
Less than 1.
yeah, less than 1. So the limit as s goes to infinity is
0.
0. 1 plus 0 is 1. Great. That thing, where does that thing go to? 5 over 4 to the n.
Infinity.
Infinity. So what is this limit? Infinity over 1, which is infinity. So what can I say about this series? Diverges. Okay? Are we good? Any questions on this? Okay. Let's find more. What about this here? Yeah.
You can do a direct comparison. If you expand the n to n squared plus n,
Sure.
it will always be, it will like act the same as 1 over n squared.
That's right. So you can do that by limit comparison, or by comparison. Right? Are we good here? And what's another way we can do this? If I tell you find the value of this series, can you actually find the value of this?
So that's telescopic.
It's a telescopic series, right? You see that? Write the top as n plus 1 minus n, and then simplify it. Okay? Do you want, I mean, let's look at here. By comparison, or limit comparison. I mean, comparison still works here. With Bn. First, An is positive, right? That's what I need for it to be positive, right? It's not negative, of course. Yeah. And Bn is obviously positive. Now the limit as n goes to infinity of An over Bn, what is it? This is just the limit as n goes to infinity of n squared times n plus 1, which is 1, right? Yeah, we see that? So, since then is the convergence absolute here or not? Is the convergence absolute?
Mm-hmm.
It is absolute. Why? Because my terms are already positive. Okay? Okay? Great. Let's do one more.
If you wanted to do the telescoping, it would be n plus 1 minus n.
Yeah, so here, if you want to do telescoping, that's a good point. Let's bring it. Let's do this. But let's find the value of this series. Can we find the value of the series? Yes, we could. So I mean, what you could do is then truncate the series at n, and then take n to infinity. So we can find the values of the series. We know it converges, so now we can just write this. Is the limit as n goes to infinity let me write this way. K plus 1 minus k over k times k plus 1 k plus 1 is just 1 over k minus 1 over k plus 1. Right? Yeah? Agree? We see this? We see how this simplified? Okay, now what is the sum from k equal 1 to n? 1 over k. So it's the first, the very first, and the very last term that say, right? This is just limit. Okay, so this series is equals 1. Any questions? Questions? Okay. Let's find out series actually. Don't hesitate to ask. I'll try to find nice questions actually. Just a second. Okay, we good? Now, take this series. How do I do this one?
Root test.
The root test is the best test that I could do, right? Why is that? I have something when you take, well, let's try the root test. So that's an n squared. So I take the absolute, is an positive or not?
Yeah.
An is positive. So an to the 1 over n, what is that? This is just to the n, right? What is this limit as n goes to infinity? E. So does it converge? So series diverges by the root test. Okay, so it's good you guys are comfortable with this stuff now. Let's look at this one. Okay, so anybody wants to help me? Is this series like always series positive or negative, or so?
Can you take the absolute value of it and bound it by 1?
Sure, that's the thing to do. So sine 2n is less or equal than what? Right? Agree? Now, this is, of course, this is non-zero. This is bigger or equal to 0. What can I say about this?
Geometric series which converges.
Exactly, so this one converges. So by comparison, this one must converge how? So this one converges?
Absolutely.
Absolutely. Right? Since converges, then by comparison, converges. So this series converges absolutely. Okay?
Alright, how did you determine that it converges absolutely?
Because the absolute value converges. The series of the absolute value converges. That's right? So if the series of the absolute value converges, then by definition this converges absolutely. Okay? Is that clear? Great.
We should try some more. Let's see if we could try some more. Let's try this one.
We haven't seen one that is still conditionally convergent, right? Yeah, we haven't seen one. So let's do one that is conditionally convergent now. Nice example. Usually, conditionally convergent is when like the series is alternating. These form like very good examples. Okay, so what about the series? Are the terms always positive? Are the terms always negative? Is it alternating? Does it alternate sign minus plus, minus plus, minus plus? Okay. So what can I apply here? The alternate series case, right? If provided I have many conditions. What are the conditions that I have that I need?
Decreasing greater than 0, and the limit goes to 0.
0, right? Very good. So provided this is decreasing, goes to 0, and is positive. Is this positive?
Yeah. Yeah.
Of course. Does this go to 0?
Yes.
Of course. And is it decreasing? Of course. Let's try it. So that's f of x. And what's one way of trying it is by derivatives usually, okay? For x bigger or equal to 0, what is f prime of x? Minus 3x squared times x squared, so it's minus 3x to the 4. That's nice, isn't it? Over. So it's 3x squared. 3x squared times x squared. So 2x to the 4 minus 3x to the 4 is just minus x to the 4. Plus how much? 8x. Right? over. So I factor an x out, I get minus x cubed right? Agree? Now if x is positive, this is positive. This is always positive, right? Because it's a square. Now, for one, can I guarantee that this number is negative? If x is bigger than 2. If x is bigger than 2, then f prime is negative. So f will be decreasing from 2 to infinity, right? We see that or not? Everybody, we see that? And to infinity, which means that an, and this is kind of obvious, right? Because an it will behave like what entity?
1 over
An is like 1 over n, right? You have n squared here and n cubed here. So these are the dominant terms. So n you can expect it to behave like 1 over n. So this is not it's not how do you say, it's not a surprise that it's decreasing eventually. So an n squared over n cubed, of course, is decreasing. Or n bigger or equal to 2. Now an is positive. There is 0. So by the alternating series test, now is the convergence absolute or conditional? Conditional. Why is it conditional?
Because you
It's 1 over.
We can compare the series with n squared over n cubed, which is 1 over n,
Exactly.
and which is the divergence. Awesome.
Very good, thank you. So let's take the absolute value. Hey, so this series stuff is actually good, right? Like, everybody's good with this stuff. Yes, sir.
Would you, on an exam, would you have to take the derivative, or is it enough to say that the degree in the
Yeah. So I'll try to avoid situations like that. Okay? I'll try not to give you something like that. But in general, taking derivative is safe. Okay? Take derivative is safe. Okay, now if it's a multiple choice, then you know. But yes, sir.
Could we show n plus 1 is less than or equal to
Sure.
0?
Sure. You can show that. I think here maybe a bit farther. though.
Here it's farther,
Yeah.
but you don't know.
Maybe here maybe a bit farther. Or you could show that an plus 1 over an
Is
less
less than or equal to
yeah, exactly. Equal to 1 if the terms are positive. Oops. So, well, but some diverges by comparison with what? With what?
1 over n.
1 over. Okay, I mean, you can do it this way. 0, and then you take 1 over n cubed. Oh yeah, that doesn't do it. That doesn't do it. No, that doesn't do it. By limit comparison. Of course, this is positive, since an is positive. And harmonic series diverges, then
With
diverges. So my series, how does it converge?
conditioning.
Condition. Awesome. Okay. Great. Should we do one more? Yes, sir.
I had a question about like the question you already did. There was a part you used like the root test to test like,
Yep.
and we were getting like the limit as n goes to infinity of, yeah, that one.
Yeah.
And you said it in e.
Yeah.
Is it supposed to be e or e to the 0, which is 1? If you work out like the limit.
This limit,
Yeah.
this is e to the 1.
E to the 1.
Yeah, so whatever you have here, that's e to the 8. Okay. Did you see this? How to do this?
Yeah, we used to do like you introduce law and then
Exactly,
then you
exactly.
do that value.
And then you do l'hôpital, right? You bring the x down, right? So you take 1 plus 1 over x to the x. So you take a ln. So you get ln 1 plus 1 over x times x, right? But you don't want that. You want to apply l'hôpital. Okay? So the limit of the ln is 0. This limit is 0. And when you take back to e, no, the limit of the ln is 1. When you take e back, you get e. Okay? Great. Awesome. So let's do one more. This one is a yeah, who can help me? Yeah,
It converges absolutely.
compared absolutely. Why is that?
Because the exponential increases like way faster than n.
Okay, exponential decreases faster than n increases. Yeah, that's the good logic here, right? This is the good logic. But why is that? How do I prove that rigorously now?
Ratio test.
The ratio test. Is that what you're going to say?
Yeah.
The ratio test? Thank you. So let's try the ratio test. Okay, so I take an. What is an plus 1 over an in absolute value? Let's do this. So the minus 1 to the n, we don't have to worry about it. So let me just write this like that. So the limit that then goes to infinity of the absolute value of n plus 1 over n plus 1 over n goes to 1, e to the minus 1. So this is just 1 over e, which is less than 1. By the ratio test, this series converges absolutely. Very good. Okay, let's do one more. Any questions? Yes, sir. Oh, yes, ma'am. Sorry.
We learned something in, I'm not sure that we learned it in, we learned the series straight up, so is that an, like, determining of argument?
So you want to say that the e to minus n goes, will kill the n. I mean, it's for you to think, you know.
Oh.
Once you're at your answer, I don't want to see it. But once you see the problem, say, okay, I know what the answer is, let me just prove it. Then sure.
Okay.
Okay? But I mean, in case you're stuck, just write it down, okay? You may be able to get some partial points for it, okay? But it's not, yeah, okay? I mean, technically, the whole series business, like, if you introduce this rate of growth stuff, how fast it grows and how things, this whole thing is, you can do it in like one line. So, but I mean, it's good to justify, right? Let's do one more. Let's do one more. So limit -1 to the n over times sine pi over n. So what about this series?
Divergence, limit comparison.
So let's see. So why does it diverge?
If you compare to pi over n,
Sure.
the absolute value could diverge, but
Okay. That's so if I have any convergence, it must be conditional, right? Because the absolute value diverges. We see that or not? We see this or not? Everybody, do we see that? So what's the absolute value? So sine pi over n is positive because n is an integer. So we start sine pi, which is 0. Sine pi over 2, which is 1. Sine pi over 3. So they're all bigger or equal to 0. Sine pi over n is positive. Great. What can I say about sine pi as well? Decreases eventually. Sine pi over n as n approaching infinity. So on 2 to infinity, basically, it's decreasing. So for n is decreasing. Agree or not? Agree? Sine pi over 2, sine pi over 3, sine pi over 4. Is that right? Yeah? You see that? Sine pi over 4. And what is the limit?
Zero.
Why is that? Sine pi, because pi over n goes to
Zero.
0, which is sine 0. Okay, so what can I apply here?
Eight.
Yeah? No, well, for the conditional. Yeah? Alt?
Then
Alter?
82.
Yeah? You can apply the alternate series test. by the AST. On the exam, I don't want to see any ASTs. You write the full thing. Okay. By the AST. What can I say about it? Converges, right? Now, does the absolute value converge? But what do you want to compare sine phi over n with? Yeah, phi over n. What is this limit? It's the same limit as sine x over x as x approaches 0, which is 1. Of course, pi over n is positive as well. So diverges. So what can I say about the convergence here? It is conditional. I feel those web works helped a lot, huh? Everybody knows their tests very well. Let's do one more. We do one more? What if I replace, let's say, the sine by cosine? What do we get? I replace the sine by a cosine. Divergent, yes?
Yeah, divergence.
Okay. Diverges or converges? Why does it diverge? Because the alternating series test doesn't work. I don't want to see that. This is not true. Okay? Why does it diverge? You cannot say, okay, well, if the alternating series test doesn't work, then it diverges. Right?
The limit is not zero.
The limit of
The
limit of the absolute value of cosine 1 over n is what?
1.
1. So this limit does not, if I put a cosine here, the limit does not exist. Right? You see that?
It doesn't?
Doesn't.
The limit is cosine zero?
The limit of the cosine
Oh, okay.
of the absolute value exists, but the other limit does not. Let's see what we can. Diverges. Since, I mean, if it's convergent, if it's converged, what would I be able to say about the limit of the absolute value? 0, right? So if the limit of the absolute value is 1, or doesn't exist, or is non-zero, then the series automatically diverges. Okay? We do one more like that, so let's do that. Let's see. Let's see, what can we do? So, what is this? Divergence. Why? The limit of the absolute, yeah? Exactly, so the limit of the absolute value. I mean, our plan is positive, right? Our plan from 0 to infinity is positive, right? Thanks. Okay, are we good with this, or should we do a bit more? We could do a bit more. I just wanna find some, yeah, okay, let's just do a few more. Yes, sir.
If the limit there is non-zero, it means even conditionally it doesn't converge.
Even condition doesn't converge. Because if it converges conditionally, then the limit of the term would be 0. So the limit of the absolute value would be 0. Yes, sir.
For the cosine one, it didn't pass the alternating term that it was negative at some point, or?
No, because it doesn't converge to 0, right? The limit of cosine doesn't go to 0. Pi over n goes to 1. Okay? This one. I'm making stuff up. Usually when I make stuff up, it doesn't for itself. But I think it should be fine. I think it should be fine, yeah. So? Yes, sir. We can use the integral test. But before I use the integral test, what do I need? Positive. I need positive? Are my term positive? So I have f of x, so n4 is equal to f of n, where f of x is x to the 4. Okay, great. How do I show that f is decreasing? What can I do? I can differentiate that. Yeah, sure, let's differentiate that. But I think it has a nice derivative. I don't know if anyone tried it. I think it has a nice derivative. Let's say 4x cubed e to the minus x5 minus 5x to the 4 times x to the 4. I'm messing something up, or that's good? 4x cubed, now derivative of this term. So what is this term? This is minus 5 x to the 4. I have x to the 4 here. Is that right?
Mm-hmm.
Yeah?
Can you just say that since it's like basically n to the 4 all over en to the 5, that en increases faster, or you want to prove it by the...
It's preferable that you write this down.
Okay.
Okay? It's preferable that you write this down. So what do I get here? I can factor e to the minus x to the 5. And then I factor x to the 3, say, right? Let's factor x to the 3. So I get 4 minus 5. How much is left here? X to the 5, very good. Minus 5x to the 5. Okay, so if x is bigger than 1, I'm already negative, right? So if x is bigger than 1, that's a nice one. That's very nice. Didn't expect it to be that nice, actually. So Trying to look for harder ones though. Trying to look for harder ones. So folks, what is it? Oh, okay. Those look good. Those look good. So, what can I say? AN is? AN is decreasing. It's clear that AN is positive. And what can I say about the limit of AN? Well, f of x as x goes to infinity. Wait, what? F of x as x goes to infinity. Of what? Of x to the 4. What is that equal to? 0. Okay. You're gonna see that, how you can do that. You can do this by L'Hopital, or you can do this by series, maybe. You can do this by series, maybe. Oh, no, you cannot do this by series. No. Well, anyways, let's not worry about that. Okay, now let me try one more thing, just. Okay, let's do one more. Okay, so by the integral test. Oh shoot, f is continuous. Whenever I say f should also be continuous, right? But when I differentiate f, if f is differentiable, then f is continuous, okay? And f is continuous. Of course, this is the very most important one. And decreasing. Okay, here you can do it with L'Hopital, I think. You can do it, the easiest way is L'Hopital. Now, I don't know if you can do it another way. I think L'Hopital is the easiest way, but it's, yeah, okay. I mean, what you can do here, so you have x to the 4 over e to the minus x to the 5, right? Okay, over e x to the 5. That's what you have, right? Yeah? So what I would suggest is that, put it this way. Yeah? You can do it this way. And then work with, in case you're stuck, u over e to the u. By L'Hopital, what is that? This is 0, right? Do you agree? This is 0. Infinity over infinity differentiate, 1 over e to the u becomes 0. So this here is 0, right? And this here is 0. Okay? Instead of L'Hopitaling like 55 times. I mean, I think you need to L'Hopital 2 or 3 times. Okay? Yes, sir.
Wouldn't you only need to L'Hopital once because the x's cancel?
Do they? Oh, yeah, maybe they do. See, I'm very bad at differentiating. 5x to the 4. Yeah. Yeah. X cubed. Yeah, x4. So yeah, that's right. See? Very bad at differentiating. Very bad at this stuff. Series are nicer though. Series are way nicer. Okay, let's do one more now. Now we'll have to think a bit more. Convergence by integral test. Did I integrate this or not? I didn't integrate this yet. Okay. So let's look at the integral. What is integral to x4 e to the minus x5 dx? What is this integral? So let's see, this is minus e to the minus x5 over minus 5, right? From plus infinity, did I start at 2? So this is 0, and then what do you get? You get e to the 32 over 5, which is fine, right? Did I get this right? Yeah, okay. Usually, I don't do my u subs, so let's see. So u is, oh my, okay. Let's differentiate this thing here. You get minus 5x to the 4th, minus 5x to the 4th. Oh, let's put a plus here, actually. This is a plus. Minus 5x to the 4th. That's minus, divided by 5, so that's what you get, right? My integral test. Okay, now a more interesting problem. Now more interesting problems. Converges. Are the terms positive? Yes. So the convergence is absolute. Okay, great. Now, how do I get the next one? That's a good one.
Why is the lower bound 2?
Why is the
Lower
I
bound.
think I started at 2. Did I start at 2 here?
Sorry.
Doesn't matter. Doesn't matter. 1, 2.
Yeah.
Yeah. 3, 4. You can put any number, any positive numbers. Great. What about this one? Looks ugly, huh?
Could you see that the lowest value you can get is 1? So if it's not that value
Sure.
greater than 1.
Sure. So you mean e to the 1 over n is greater than 1. So here, are these terms positive? These terms are positive, great. Now what do I know about this limit? You can do it in many ways, many ways. What is this? For L'Hopital, or this is just the derivative of e to the x at 0, right? E to the x minus e to the 0 over x minus 0. What is this limit? Or just L'Hopital it. 0 over, you get 0 over 0. L'Hopital it, what do you get? 1. So what's a good thing to compare with? E to the 1 over n. If I let my x be 1 over n, and n goes to infinity, right? So if n goes to infinity, where does 1 over n go to? 0, right? So what's a good term to compare this? What should I compare this with? 1 over n. You see that? If I compare this with 1 over n, so e to the 1 over n minus 1 is bigger or equal to 0. What is this equal to? Let this be x. If n goes to infinity, x goes to 0. This is just 1. Since 1 over n is also positive, okay, by comparison, or by limit comparison, what time is it? 3:30, okay. Sigma n equals plus infinity goes to what? Diverges, right? diverges since okay, is it clear? I think the level is similar to to these questions. Okay, this is the same level of the question of the quiz, right? Yeah, you see that? Some maybe, I don't know now if this one may be a bit harder, but in general, this is the level you should expect. They're not that bad, okay? Just check that you know your series, you know your tests, you know the conditions, and so on. If you want, we can do more series, or we could just move to power series. What do you prefer? Power series. Okay. Let me find first. I'll do some exercises. You know, find the values of x for which this converges. Is that fine, or we can skip that? We do. Let's do some of them. Let's do some of them. Okay. For which values of x does this series converge? You'll have a question like that, okay? The question that I gave you on the quiz are just the same question that you would have on the final, on the midterm, but it's gonna be different series, of course. It may not be the same series, or it may be. Who knows? But I can't remember what I put in there, but I don't know. Great. So find for which values does the series converge. Let's do three examples. We do 3 examples and then we move on to series. Okay. Okay, let's try that. What's a good way to start these things?
Ratio
Yeah?
test.
Ratio test is a good way to start these things. So, what do I get? If the ratio tests, when I take the quotient of the absolute value of these two functions of x, basically, right? That they depend on x. If I get my limit strictly less than 1, what does the ratio test tell me? Converges? Absolutely. Great. Now, if the limit is strictly bigger than 1, what does tell me? Diverges. Now, if the limit is equal to 1, what do I have to do? I have to check endpoints manually, right? I have to check them, each one on its own. Now, is the convergence at the endpoint necessarily absolute? No. Okay, so if it converges, it's not necessarily absolute. Okay, great. Let's do this. So, what do? I take the ratio test, and I'll just call it AN. I will not call it AN of x, I'll just call it AN. AN plus 1 over AN, what is that? It's just xn plus 1 over n plus 1 to the 4 times 4 dn plus 1 times 4 to the n and 4. What do I get? I get absolute value of x times what? Over 4, right? Times n over 4. What is this limit?
X over 4.
X, absolute value of x over 4. So my series on what interval I am sure that it converges? Negative 4, 4. Included or excluded, I'm sure? Excluded. So, series converges. What can I add here? What can I add? Converges how? Absolutely. If x belongs to minus 4, 4, and diverges if x is strictly bigger than 4 in absolute value. Okay, now what do I have to check? I have to check the bounds. What are the bounds?
Minus 4, 4.
Minus 4, the upper, the endpoints, minus 4 and 4. So let's plug in x equal to 4. What do I get? 1 over n to the 4. Does it converge?
Yes.
Why?
P series.
P series, and P is bigger, strictly bigger than 1. Awesome. Now if x is minus 4, what do I get?
We can.
Minus 1 to the n over 4. Does it converge? Why?
The absolute value converges.
The absolute value converges. Or, if you wish, by the alternating series step. But, since it converges absolutely, we don't worry about this. Okay? We see that? So if x is equal to 4, let me write this, x to the n. Converges. And if x is equal to minus 4, what do I have? Okay, so minus 4 to the n over rho to the n, this is just converges, also absolute, right? So the interval of convergence, what is it?
4.
Minus 4, 4. What do I include? Do I include the minus 4 or not?
Yes.
Do I include the 4?
Yes.
Okay, very good. Awesome. Awesome. Interval of convergence. Minus 4, 4. Let's see here. Let's try something here. Let's try this one. So what do I want to try here? What's a good thing to try? The ratio test. So let an yeah, sorry, I didn't put 2, very good. So what is an plus 1 over an? Guys, let me write this here. What is an plus 1 over an? An plus 1 over an, what is it? So let's write this down. the first term is just x to the 2n plus 2, right? In absolute value. Then I have 2n plus 2. Then ln n plus 1, is that what I have? Times what? Times n plus 1. So on top I have 2 to the n plus 1 ln n times n. And then what do I have on the bottom? x2 to the n. Great. Then what? So I have x squared. Let me simplify that. X squared. So I have a 2 here, right? And let me write this way. Ln n over ln n plus 1 and over n plus 1. What is the limit? What is this limit?
X squared.
X squared over
2.
2. Why is that?
Because both of these goes to 1.
This one goes to 1 is obvious, right? Why does this one go to 1? Who wants to help?
L'Hopital.
L'Hopital, right? Right? L'Hopital, you can say that this goes to 1. You get 1 over x over 1 over x plus 1. Which is x over x plus 1, which goes to 1. Of course, you have to check that the form is infinity over infinity. Is x squared over 2, and I should have picked a 4, but anyways, I should have picked a 4, but that's not a problem. That's not a problem. Anyways, now it's gonna get ugly, but that's okay. Since the limit as x goes to infinity of log x over log x plus 1, this is infinity over infinity, right? So by L'Hopital, is just the derivatives right? And then the limit and then goes to infinity n over n plus 1 is 1. Great. Now, for what values does this converge? On what interval? So what do I need? I need x squared to be strictly less than for it to converge.
1.
X squared over 2 strictly less than 1. So x squared strictly less than 2. So the series converges. How could I say it converges if it's strictly less than 1, if this limit is strictly less than 1?
Absolutely.
Absolutely. Do you guys find this helpful? Is it good or?
Yeah.
Yeah. Okay. If x squared, I mean, it doesn't matter, strictly bigger is strictly smaller than 2, and diverges and this is equivalent to x belongs to what interval? Minus root 2, root 2. Right? We agree with this? If x squared is strictly less than 2, then x belongs to minus root 2, root 2. Great. Now, if x is equal to root 2, what can I say about this series? Yes, yes.
But I'm trying to see, but until one time I have to do
Yeah, so I'll do like 20 more minutes. So at like 4:05 or 10, you guys can ask your own questions. Okay?
Excuse me, what is the radius of convergence?
Here? What is the radius of convergence? So take this interval, right? Take this interval.
And then add them and then over to.
Exactly. Not add them. So, like, find the distance between these 2 points, which is 2 root 2.
Absolute value.
Exactly. Divide by 2. What is the integral of convergence?
Root 2. Root 2.
Yeah, because x squared is less than 2, right? Is equivalent to absolute value of x is strictly less than root 2. Okay, you can read it up here. Okay? So, great. Now, what do I have to check? Now, that's an interesting question.
The bounds.
The bounds. So if x is equal to what? Let's start with the easier one. If x is equal to minus root 2, what do I have? Minus root 2, right? What is the series equal to? Well, does it matter actually? Does it matter?
No.
You notice that this is an even function of x, right? If you plug in a and if you plug in minus a, you get the same answer, provided that this series converges, right? So, if x is equal or x is root 2, and you know when you take a plus or minus here, doesn't matter because the 2 will kill it, right? What do I have here? What do we have? 2 to the half. So 2 to the half squared, which is 2 to the n, right? 2 to the n. So what do you get? You get 1 half n ln n. Okay? Now, how do I do this? What's one way of doing it? Integral test, right? Is this decreasing? Is this continuous? 1 over x log x. Is it continuous? Yes? Is it decreasing? Is it decreasing or not? Clearly, because x increases and log x increases, and they're both positive. So when you take 1 over this, what do you get? It's decreasing. The limit of 1 over x log x goes to infinity, plus infinity. So when you take 1 over that, where will it go to? 0. Okay, so I can apply my integral test. My integral test, I can integrate that. So 1 over x log x, what is that? This is u prime over u, right? U prime is 1 over x over log x, so u prime over u. What's an antiderivative of u prime over u? It's log of the absolute value of u, right? Yes or no?
Yes.
The wrong way. Oops. Let's see. Oh. Anybody okay? That's too complicated now to get out. Okay, I'll do something here. Okay, sorry about that. Okay, I don't appear. That's good. Okay, great. Okay, now what is it? You guys see by the integral test? You can do a u sub, you can do u equal ln x, but we should not be able to, you should be able to spot integrals like that. Okay, so let's write this. Uh, 1 over n log n is equal to f of n, where f of x is 1 over x ln x, or x bigger or equal to 2. Okay? Now, f of x is clearly positive, right? Because x log x is positive. And x log x is increasing and positive. So 1 over x log x is decreasing. You guys have seen these theorems in Calculus 1? Yeah, don't try to compute the derivatives. Just immediately, these are obvious. 1 over things, x log x is increasing, and strictly positive on to infinity. So f of x is decreasing, and positive on to infinity. And what can I say about the limit of f of x? It's equal to 0, obviously. So what can I apply now? And f is continuous, of course. You could put a closed interval, but it doesn't matter really. So what can I apply? I can apply the integral test. So integral 2 to infinity. What is it? It's 1 over x ln x. So you can do a u sub. U is equal to ln x, right? So you get the integral of 1 over u, or you can just see it immediately. This is the integral from 2 to infinity. Well, this is log of log x in absolute value from plus infinity to 2. What is that? Does it diverge or converge? Diverge, right? This is plus infinity. So diverges. What is the interval of convergence of my series?
Open bracket.
Minus root 2. 2. Both or one of them is open? Both are open. Interval of convergence. Okay, are we good here? Is it clear? It's all nice work. Now let's move on to series. Okay. Okay, any questions on this part? Any questions on this? Okay, let's move on to series. Okay, I mean, I'll assume that you guys know all the stuff, all the series, okay? And then we'll just start by asking some questions. So let's do something nice here. I want to find something nice. Hold on. Just please bear with me 1 second. You know, I can just do my own stuff, but okay. Wait, what? Well, sorry about that. Let's find something nice, actually. Okay, great. So, find the series of, let's see, what do you want to do? Someone give me a number, integer, positive integer, of e to the 7x number, 17, okay.
If we wanted to find tan, would we do the one of sine over the one of cosine?
It's going to be harder, right? Unless there's a way. I mean, I've never. Well, I mean, you know the first few terms, right? It's x, so it starts with x, right? Then, I mean, technically that's one way to do it. You have to do long divisions between two big polynomials. You'll never finish. But I mean, you may be able to find a pattern, maybe. I don't know. So.
What's the best way to do the derivative of x factorial?
Yeah, that's one way. Or
Like, we're not gonna get 10.
no, then you're not gonna get it. Because I don't even know it, right? Like, if I don't know it, then you're not gonna get it. Around, so someone suggests a point. So a number in the back, someone give me a number. 6, let's say. Around A is equal to 6. The Taylor series. Around A is equal to 6. Okay, now that's gonna be. That's not easy, right? A priori, this is not easy because. What do I know about E of A? What do I know about E of A? E of A is equal to sum n equal to 0 plus infinity, a to the n over n factorial for, and what is the radius of convergence of this thing is r, it's infinite, right? Yeah? The limit when you take the ratio test is 0. So the radius of convergence is infinite. For any number this works. Great, I mean, and then we can show by the Lagrange remainder that this is in fact true. Great, around A equals 6. Now, what do I need to put here? I need a x minus 6, right? This is what I need. So how do I transform that to get an x minus 6? So what I gotta have 7, well, x minus 6. But I still need something to make my math work. Do you agree or not?
Yes.
So what should I be adding? So what did I remove here? I removed 42. I should add them back. 42 plus 17, what is that? 59. Do you agree with this equality? Everybody? Now, what else can I do? How can I play with my E? This is just E59. Agree?
Yeah.
Now this is a constant. Now here, what can I use here? If I use this formula here, then I'm good. Am I not?
Yeah.
Because it will give me something around x minus 6. E59, what is that equal to? This is sum n is equal to 0 to plus infinity, 7 to the n, x minus 6 to the n over what? N factorial. Are we good here? Now what's the, let's see, what's the second derivative of f of x at 6? F double prime at 6 is equal to what?
Replace n by 6.
Exactly. So I look at the coefficient of x minus 6 squared. What is the coefficient of x minus 6 squared?
7 to the power of 2 over 2 factorial.
Times
E15.
E59. Okay, now did I forget something? What should I multiply by?
N factorial.
2 factorial. Very good. 7 squared times e to the 59. Okay, you can differentiate that, but I think it's clear, right? You can see this clear. Okay. Let's do one more. Find the series of, let's see. Of x. Find the series of, let's see, find the Taylor of f of x. Who wants to give me a number? Let's try something a bit more. Let's try x, actually. let's try Q. Okay. Around A equals 0. And use it to find, let's see, so F, let's take F17 at 0, F18 at 0, F19 at 0. And maybe we can add one. Great. Now what is cosine A equal to? Everybody, what is cosine A equal to? We all know the series of cosine. Cosine A is what? Sum n equal to 0 plus infinity. Someone? Just one person? Yes?
Negative 1 to the n.
Yeah?
Multiplied by x to the 2n.
Yeah, I have an A here, so, okay.
Oh.
Divided by
2a factorial.
2n
Factorial.
okay, for any A in R. Okay, now let's look at this here. What is f of x? X cubed. X cubed is already a power of x. Do I have to change it? No, so that's fine. X cubed. What is cosine of 1/2 x squared? What do I replace? Where does the 1/2 x squared go? A. So what is that? This is sum n is equal to 0 to plus infinity minus 1 to the n x squared, well, 1/2 x squared to the 2n. Okay, that's nice. Well, maybe not so much, but let's do this. This is x cubed. Sum. So minus 1 to the n. 2 to the 2n. What is 2 to the 2n?
4.
4 to the n, right? 2 to the 2n, what is that, everybody? 4n? 4 to the n? 4 to the n times 2n factorial times x to the 4n, right? Is that true? Yeah? Times x3. So what do I get here? Minus 1 to the n. Are we sure that this is good? Let's double check. Let's double check. Is it good? Are we good here? Is it good?
Yeah.
Yeah, did you guys check it? Is it good? Oh, okay. I was thinking of something else. Okay, 4n divided by 2n factorial. This works for what x? Any real number x, right? This works for any x in R. Okay, now what do I need to find? I need to find F17, F18, and F19. Like the 18th, 17th, 18th, and 19th derivative of f at 0. Great. Now, the 18th derivative. Where do I look at? So what do I need? Yes. 4n plus 3 is equal to 18. So I look at the coefficient of x to the x to what? To the 18th, right? Now, what is the coefficient of x to the 18 in that case? 0. Why?
It doesn't exist.
There's no integer n that gives me 4n plus 3 is equal to 18. Are we good here? Everybody, are we good? So if I solve 4n plus 3 is equal to 18, what is the value of n that I get? Do I get an integer?
No.
No. So what is f18 of 0? The 18th derivative of f at 0?
Yes.
Agree? So far so good. Now I want to do the same thing for 17. For 17, what can I say for 17? 0, right? What's the coefficient of x to the 17 in that case?
0.
We see that?
Yeah.
Can 4n plus 3. So what are the non-zero coefficients of what powers? So x cubed, then x7, x11, x15, and then x19. Okay? Okay, now F19. What do I look at? I look at the coefficient of x to the 19. Okay, so what is the value of n? For what value of n do I get x to the 19? N is equal to 4. So what is the coefficient I'm looking for? It's C19, well, it's C19, but for n, okay, depends how you formulate it, okay? But what is the coefficient? I mean, the number shouldn't change here. For n is equal to 4, what is the number I'm looking for here? Minus 1 to the 4, very good. Times, divided by 4 to the 4, times 8 factorial, did I miss something? Times 19 factorial. Okay? Is that clear? Do you want to do one more like that, or that's fine? It's fine? So, yeah, okay. These are the questions you're going to have on the midterm. On the final, of course, they may be harder, okay? But on the midterm, you're going to have questions like that. And then an extra question on partial derivatives, the things we did on Thursday. Yes, sir.
Did you take your midterm and exam questions from the textbook, or did you make them up?
I don't know. I forgot how I wrote it like maybe the second day when I just knew that.
Same. You can pass it.
No, I wrote it.
You wrote
But
it.
I wrote it immediately after we started the lectures because I knew I'm going to examine the first 5 lectures. Okay? So, but I mean, do the book. Okay? Do the book. They have very nice questions. Okay, so I'll stop the recording. Any more questions on this stuff? No. Okay, great.